Hello, everyone. Welcome to Azure Developer Community. We are back with yet another session on fundamentals of Azure Databricks, Lakehouse platform, and Delta Lake with a new speaker, Sagar Lad. Sagar is a technical architect with a leading organization, has a deep expertise of designing and building enterprise-grade intelligent Azure data and analytics solution. So he's a subject matter expert in this particular area. So welcome, Sagar, and thank you for accepting our invite to join in our community and host a session as a speaker. Over to you, Sagar.
Thanks a lot, Asivat, for a warm welcome. So, first of all, I would like to thanks everyone for joining the session. Today we are going to talk about an interesting topic that is basically fundamentals of Azure Databricks, Lakehouse platform, and Delta Lake. It is going to be a series of sessions. So this is the session where first session from the fundamental that we are going to cover. I'm working as a technical architect for one of the consultancy companies, and currently I'm living in Netherlands. So looking forward to connect with all of you, and yeah, I will start with the session. So feel free to put your questions in the comment section. So we will take up all the questions at the end. Uh, so yeah, Let me start with the agenda for today's session. So we are going to first have a walkthrough about origin of Lakehouse platform. After that, we will also look at the challenges with the current data lake implementation. So basically, initially there was an era where we were building data warehouses. Then after the introduction to cloud, we were building data lakes, and yeah, there were still some challenges and how it can be overcome with the Lakehouse platform. After going through the introduction of Lakehouse platform, we will look at the actual offering of Databricks platform on Azure and its components. And then we'll also look at the actual Databricks platform use cases, which is being implemented by multiple enterprise organizations, and we can all and how you can leverage it to build your end-to-end data and AI solution. And at the end, we will take up different all the questions that you have, if any. So let's try to have an interactive session. And yeah, let me start with the session. So first, we'll look at the origin of Lakehouse platform. So basically, yeah, let's start with what is Databricks. So Databricks is basically a software as a service data and AI company, the company's main goal is to simplify big data and AI and making it easy for the enterprise organizations. So basically, they are using various open source platform tools and technologies to create like software as a service, data end to end data and AI solution. It also enables data-driven innovation with different enterprises. It brings together all of your data, analytics, and AI into a single lakehouse platform, which will overcome all the traditional challenges we have while building data solutions. So all the different data engineers, data scientists, as well as data analysts can work together onto a single platform, avoiding the challenges with compatibility of different tools, etc. And one of the very like major advantage of using Databricks is it is powered by open source technologies like Delta Lake MLflow. So which combining the power of Delta open source technologies with the Databricks platform makes it a really good platform to be used for end-to-end data creating an automated end-to-end data solutions. And as I already mentioned at the beginning, it combines the best of data warehouses and data lakes to create a single lakehouse platform for the overall your data and analytics solution. Let's start. Basically, Databricks is a software as a service company, and when we talk about Azure Databricks, it is basically a Databricks tool. It is an abstraction layer on the top of existing data platform, which is created for Microsoft Azure services and offering. to use this solution on the top of Microsoft Azure cloud with a single click of a button to create your data solution, and you don't have to worry about underlying configurations, underlying Spark configurations and other configuration to create your platform. So you as a application team or data development team or data engineering team, you can completely focus on creating your application development, focus on your application of components, features, etc. The underlying infrastructure will be taken care by the cloud provider as well as Databricks. So Databricks Databricks provides its cloud offering onto three different platforms. For now, it is Azure, AWS, and Google Cloud. But for this session, we are going to focus more on the Databricks availability on Azure as a platform and how we can leverage it to work with Azure services to create your data and AI solution. So basically, with Azure Databricks, it can support all multiple types of data like structured, semi-structured, unstructured, and it can also support streaming as well as batch pattern. In addition to that, it can also work with the big data or huge amount of data to create your application to create your data application. So it has an open data storage. So Databricks has its own data storage. It is named as a DBFS, so Databricks File Storage System. Uh, on the top of this storage, Databricks also provides data management and governance basically. So when we talk about data management, how efficiently you can ingest and transform your data into Databricks, as well as also how you can govern your data solution. So we know there are, let's say we have GDPR as an example, where data security or data leakage is one of the major factor when you create your data solution and you don't want to expose your sensitive data outside your organization. So Databricks has all the inbuilt feature to create to have a data management and data governed data and AI solution. So once the data management and governance layer is there, on the top of that, you can do your data engineering work basically. So you can create your automated pipelines. It can be ETL pipeline or ELT pipeline, where you can consume data from different, let's say, cloud provider or on-prem sources, and then create an ETL or ELT pipeline to extract, transform, and load the data. And once the data is available inside your inside the da- in the inside any of the storage, it can be DBFS or it can be one of the storage inside your public cloud like Data Lake or Blob Storage or AWS S3. Various business analysts can work on the top of this data storage to run the SQL-like queries to perform SQL analytics, and it also has multiple connectors available for various BI tools like Power BI, Tableau. So you can run the SQL queries on the top of data stored in Databricks, as well as you can also run the SQL queries and connect to the BI tool to create dashboards and visualization. Additionally, you can also you basically data science. You can also create data science use cases or create machine learning models on the top of data that we have in Databricks. And then you can also basically create real-time data applications. So overall, data Azure Databricks is an offering from Databricks, which is an abstraction layer created on the top of Databricks platform for to be used in Microsoft Azure services, and different teams like data engineering teams, data analytics teams, as well as machine learning and data science team can work on the same platform to create end-to-end open source and simplified data and analytics solution. So this is briefly about the Azure Databricks platform and how its offering has been customized for Microsoft Azure cloud. Now let's look at a few of the accelerators of using Azure Databricks. If any enterprise organization wants to use Azure Databricks, and what are the accelerators basically which can be offered by this tool. So you can ingest, transform massive quantities of data and different types of data. So basically, the your input of the data source can be any of the public cloud like Microsoft Azure, AWS, or GCP, or it can also be your on-prem data source where from where you can connect, you can establish secure connectivity, and then you can ingest the data from the different data sources, create an automated ETL pipelines in Databricks to perform the transformation on the huge data or big data. And it can also work with a variety of data like structured, semi-structured, or unstructured data. In addition to that, as I mentioned earlier, it is a collaborative, open source, and simplified platform. So it allows you as a data team to explore the data that you have available with various data science techniques, including machine learning as well. So it is Databricks is using open source technologies like Delta Lake and MLflow, where you can manage your end-to-end machine learning lifecycle, create centralized ML model repositories, as well as you can also create Delta, basically a Lakehouse platform which supports ACID transactions. It also guarantees the data availability for the business queries. So from the data governance and security perspective, Databricks has multiple feature where only authorized and authenticated user can get access to the data available with Databricks tool. And it also makes sure that business analyst can run the SQL-like queries to perform to perform analysis, and also create visualized dashboards with different connectors available for BI tools. It provides a simplified experience for data engineers, data scientists, and analysts, so they can work together. So earlier, in the traditional development life cycle, data engineers were working on a different tool, data scientist works on a different tool, and analyst works on different tool. So sometimes there were also challenges with respect to compatibility of different tool, and you need to spend a lot of time to transform data to be available in one tool in a to be consumed by another tool. But since now Databricks provides all the features into a single unified platform, you don't have to worry about traditional challenges with respect to your development life cycle, and you can directly focus on your respective work to create an end-to-end data solution. Yeah, and yeah, apart from overcoming the traditional challenges, you can also work with data science and machine learning workflows to create an innovative AI solution on the top of data. So basically, it will create a real value out of the data that you have present and that you have processed with the help of Databricks. Yeah, so now after covering the basics of what is Azure Databricks, basically this is how the user interface or Databricks workspace UI looks like. We are also going to cover in detail a demo about the workspace UI and different components, basically. So yeah, we will deep dive more about different components of Databricks UI later in the demo slide, in the demo part. Yeah, so I think now by now we already have a good overview about what is Databricks, what is Azure Databricks tool, and I mean what is the main purpose this tool has been created. But the main question still arises is why do we have to like what are the challenges with the current data lake implementation, and why we have to start using Lakehouse platform? Because initially when in the software engineering we were working with data SQL data warehouses, or where we were building various warehouses to store data. Later on, after the introduction to cloud platform, we started using data lakes. We started building data lakes on the top of, let's say, Azure Data Lake Storage Gen 2 or AWS S3. But still, there were some challenges due to which data lake is not enough or data warehouse is not enough, and we have to come up with a hybrid approach. So that is what is Lakehouse platform. So let's deep dive more into the challenges with the current data lake implementation. So first of all, the biggest challenge while working with data lake is complex. It is really complex architecture to work with big data. This is basically the overall the generic data implementation which will be used by most of the enterprise organizations. So if you look on the left hand side, we have data warehousing. So we have structured data. On the top of structured data, we build data warehouses and data marts. And once data marts are available, we can create analytics and we can use analytics and BI tool to create visualized or dashboards to which can be used to create business insights and can be used by business to manage different activities. So once the data warehouse is built, we have you can there are multiple tools you can use, basically Azure Synapse, Redshift, Snowflake, Teradata, Google BigQuery, or DB2. So yeah, different organization has different choices and they can use one of these tool to build their data warehouse. Then we have data engineering. So when we talk about data engineering, you can work with multiple types of data. You can create your data lake. You can create your ETL or ELT pipelines, and you can use Apache Spark, Airflow, Cloudera, or EMR or Hadoop to perform this and build this ETL pipeline to work with different variety of data as well as different volume of data. Then later on, we also started working on a real-time streaming ingestion of real-time streaming data. So basically, there can be streaming data source where we can create a streaming data engine to get the data in a real time, and there are multiple tools available. Kafka, Flink, or we have Azure Stream Analytics, Apache Spark. And once that is done, if you want to create some innovative ML machine learning solution to create some automated, let's say, KPIs, etc., then you can build machine learning models on the top of data we have prepared in data lake. And even for that, we have multiple tools available in the market. So we have open source packages like PyTorch, TensorFlow. We have Jupyter. We also have Azure Native ML Studio, AWS SageMaker, or SAS tool. Yeah, so one of the biggest challenge, if you look at the current architecture, first of all, it is quite complex and multiple interfaces needs to be set up as well as connectivity. So the Power BI tool has to be connected to the process ETL data that we have. And also, once we create basically ML models, which will create some insights, so you can connect to you have to set up a connectivity from BI tool to those ML models output. So likewise, the overall architecture is pretty complex. So basically, we are creating silos to create an end-to-end data solution. So let's say one of the challenge can be for data warehousing, we have used Azure Synapse, and for data engineering, we are using Apache Airflow. Then the biggest challenge is how you can create compatible solutions so that Apache Airflow can be used with Synapse to create your solution. But and additionally, those connection needs to be secure. You have to make sure that no data leakage can happen. So likewise, the data architecture for your end-to-end data solution become very complex. It will create silos and it will create a disconnected system, which will also make your life pretty challenging in order to once your data solution is operationalized. Then let's look at the second challenge is decreased organizational efficiency due to silos. So as we have already seen, basically we have created silos where different set of data analyst team who are working on data warehousing. We have another team, siloed data team, let's say data engineering, who is performing, who are creating ETL pipelines or ELT pipelines. Then we have basically again data engineer who are trying to ingest the data in a real time, and we have data science team who are basically data scientists to create machine learning models to create some insights. But if everybody is working in silos, then basically data engineers are not at all aware about what data analysts are doing. Data scientists are not aware about what data engineers are doing. So basically, all different teams are working on for the same purpose. But since they are working in a silos, once a development is ready, they need to collaborate, and again there'll be some exchange feedback. So overall, it will decrease the speed at which you can develop your solution, as well as also it will create kind of silos. So if there are multiple teams who are working on such data initiative, overall it will decrease the efficiency of your organization. Then the third part is data security. Yeah, so nowadays, due to GDPR and various other initiatives from different governments, you really have to be careful to make sure that your platform is secure, as well as your data is also secure. There should not be any data leakage. So in order to create secure data solution while working in silos, you have to there can be an immediate monetary cost. So one of the example can be you have build some solution for the financial institute, and in your solution it is not and your platform is not secure, and there is some intruder who is able to somehow able to get somehow able to access the PII data that you have. So it will involve a monetary cost for the organization with respect to the data security breaches. And yeah, once there is a data security breach, or if there is any monetary loss, apart from that, it will also creates distrust and loss for the customer. And whenever you are working with any data solution, and if you are dealing with sensitive PII data, personal information data, then you have to make sure that you need to spend additional effort to abide by different data protection regulators like GDPR or HIPAA. And if you are not compliant to any of the requirement from these regulatory forms, then there can be a heavy penalty for the non-compliance. So this is also one of the major challenges is being faced while with the data lake implementation. Yeah. So after looking at the challenges, we have looked at what is data warehousing, what is basically data lake, and how we can get rid of those challenges. And the solution is to build a Lakehouse platform, which is open source, simplified, collaborative, and we overcome all the traditional challenges that we have to build data solutions. So let's look at the comparison between data warehouses, data lake, and the Lakehouse platform. And then we will deep dive further into the more features of Lakehouse platform as well. So basically, data warehouses were built mainly for the BI and reporting purpose. So one of the major disadvantage of data warehouse is that it can only work with structured data. It doesn't work with video, audio, or text file. It doesn't support data science and ML. So if you're building data warehouse, basically you can store your data, you can perform analytics with the help of BI and reporting. But if you want to create data science models or machine learning models, and you have to again choose a different tool, and then set up a secure connectivity, create a governed solution, and then you can it doesn't have inbuilt data science and machine learning support. It has very limited support for streaming. So apart from the type of data that data warehouse supports, you can basically work with batch data, but you cannot work with streaming data. So let's say if you are working for a financial firm, and you are working on a use case to basically credit card false alert, let's say. So whenever based on certain pattern, if any customer, any of your banking customer is trying to do the transaction from the unknown location, then you should report it immediately via email. But because if we are using data warehouse solution, basically you cannot report it in a real time, and that cannot be used. Such kind of use case cannot be supported by data warehouse. And it is very closed and a proprietary format. So it's up, if you want to work with data warehouse, then you have to abide by certain standards, certain schema, data type, etc. And basically even different data warehousing tool have as their own format. So at certain point of time, if you want to migrate or if you want to integrate with other tools, you will have an additional challenges as well. In order to overcome the challenges with data warehouses, basically data lake came into the picture. So one of the feature of data lake is that it can handle all of your data. It can handle structured, semi-structured, as well as unstructured data. In addition to that, with the help of data lake, you can also directly create your data science or machine learning use case, but it has some limitations. So data lake doesn't have a really very close integration with BI support. So you need to set up an additional connectivity and governance framework in order to connect from different BI tools like Power BI or Tableau to data lake, which creates an additional overhead. And as I mentioned, the setup will be complex, so you need to find a different connectivity methods, and you also have to be sure that the connectivity is secure, there is no data leakage as well. And because of this complex setup and lack of support, the performance will be low. So if you want to consume the data via interactive query in a near real time, or you want to work with huge amount of data, then and the performance will not be good, and there can be unreliable data swamps if you are using data lake. So in order to overcome both the challenges or limitations that we have with data warehouses and data lake, Lakehouse has been introduced. So basically, this is the overall visual diagram of Lakehouse platform. Let's start from here. So basically, Lakehouse platform supports all different type of data. It can be structured, semi-structured, unstructured. It can work with plain text file. It can work with different type of files available. It can work with audio, video as well. Then it has advantage all the advantages of data lake. Basically, it has inbuilt support for data science and machine learning model, as well as it has all the advantages of data warehouse as well, by which you it has real good integration with different BI tools available in the market, and also good query performance with the support of Delta Lake and ACID transaction. So you can create your raw data store. On the top of raw data store, basically you can create a ETL pipeline to create a curated data, and once the curated data is ready, on the same platform, data analyst or BI developer can work on it to create dashboard. You can use streaming analytics to create real time to ingest the data in a real time and perform analytics in real time. You can also create data science and machine learning model on top of the curated data that is available inside Lakehouse platform. So basically, Lakehouse platform combines all the benefits of data warehouse and data lake, and it is completely powered by open source technologies like Delta Lake and also MLflow. So later we will also deep dive into a few of these open source technologies, but in today's session we are going to focus more on the fundamentals. So after covering the challenges that we have about data warehouses, data lakes, and how it can be overcome by Lakehouse platform, now we will deep dive further into the actual Databricks platform components. So basically, the offering from Microsoft Azure. So how we can use this Lakehouse platform on the top of Microsoft Azure cloud. So let's first start with the components of Azure Databricks. So this is basically these are the main components in the background from Databricks itself. An abstraction layer has been created on the top of these components to be available as a public offering on cloud. So first of all, uh, Databricks, Azure Databricks is using open source data, open source data lake. So you can create basically a data lake on the top of Azure. So you can use Azure Data Lake Storage Gen 2, which is cheap and reliable storage component where you can store different type of data on the top of data lake which has been built on Azure. You can basically use data lake. So data lake has closer integration with Azure Data Lake Storage where you can create your governed and data managed solution, which allows you to consume the data faster, as well as it also supports ACID transactions. And then once the delta lake layer is ready on the top of curated data that we have, we can basically perform data engineering activities. We can create BI tools. We can also work with real-time data applications, and we can also work with we can try to build various AI solutions. Yeah. So before you start using Azure Databricks, basically we have to understand how you can create Azure Databricks on the top of Azure. So basically, there are multiple ways to create Azure Databricks cluster or workspace on Azure. So you can use Azure Portal, you can use PowerShell, you can also use REST API provided by Databricks to create Databricks. So for now, we are going to check how you can create Azure Databricks from the portal. So you have to simply go to the Azure portal and then click on the plus button, by which you'll get a pop-up to create different services. So Azure Databricks is a part of analytics section. So you need to go to the analytics section and then select Azure Databricks. As soon as you click on the Databricks, basically you will be given a pop-up with multiple tabs. So in the basic steps, you have to select the subscription name, a resource group where you would like to create the Databricks cluster. You need to provide the workspace name. So this is the name by which workspace will be created. You have to specify the location. So Azure has multiple regions available, so you can select one of the region which is closer to you or which you are using it for your organization. And you can select pricing tier. So yeah, there are like three types of pricing tiers available. First one is trial version, so it will give you the premium workspace, but it you can consume 14-day free DBUs. But after that, you have to update it to the higher version. You can use premium workspace as well as you can use standard workspace. Each one has its own feature. Then the second tab is regarding networking. So by default, when you create Azure Databricks, uh, it will create Databricks workspace inside a public network available and in the background available by somewhere in Azure. But if you want to create your Databricks solution very secure, then also you can integrate it with existing VNet. So basically, there are two ways you can create custom bubble network, which is restricted only to your within your organization, where your Databricks workspace will be deployed, and all the workload, all the processing that you do will be limited to that custom bubble network. And you can also integrate your Azure Databricks with the custom VNet. So you can create your custom VNet. You can define your own NSG and traffic rules, and you can host your Databricks workspace onto the existing custom VNet, which is more preferable and which is more secure. And in addition to that, you can add more text, and once all the details have been filled in, you just have to review it. And once everything is valid, you can with a single click of a button, the Databricks workspace will be ready in few minutes. Yeah, so once the Databricks workspace is created, basically this is how the home page looks like. So here you have common tasks. So you can create a new notebook, you can create a table in DBFS, you can create a new cluster, you can create a new job, you can create a new ML flow experiment or model, or you can also import various libraries which you are going to use to create your data solution. So we will also understand in detail what these components are and how you can use it to build your data solution. And currently, the in the recent tab, every it is empty. But once you start working on it, all your present work or recent work will be published here, so you don't have to go to the workspace section and open the notebook if you are working on your recent work. And the third tab is regarding documentation. So various documentations is are available on platform like MS Docs, etc. So you can refer the documentation on MS Docs. You can refer to the release notes, because Databricks keep coming with the upgrades and the new features. And if you are new to Databricks, then also you can use this getting started feature, where you can go through some of the basics of Azure Databricks before you can start creating enterprise solutions. So yeah, so basically, after getting a brief overview of what is Azure Databricks, I think let's also go through the architecture of Azure Databricks, because that will actually give us a real good idea about how the Databricks platform is secure, and how the data that we are processing and we are storing is also consumed and processed in a secure way. So first of all, Azure Databricks has two. Basically, it comes up with two features or two components. So if you are able to see, the first one is Databricks Cloud Account, and this is the Customer Cloud Account. So this one is known as a control plane, and the Customer Cloud Account can also be known as a data plane. So customer Databricks Cloud Account will always be in the background. So basically, it has Databricks web applications, customer notebooks, jobs and queries, and cluster management. So as soon when you go to the Azure portal and you configure you provide multiple options to create Databricks workspace. As soon as you click the button, in the background, in a control pane in the control pane of Databricks network, one instance will be added, and you will be given isolated and granular access to the Databricks workspace, basically, which will manage the different customer accounts, data sets, and clusters. Then we have a data pane, basically. So data pane is available inside customer cloud account. So once the Databricks workspace is created on from the Azure portal, you can basically write different source code in Databricks. So you can basically create notebooks in R, Python, Java, or Spark. And then once your source code is ready, you can also create jobs to schedule those notebooks to run in a specific space, and the connectivity with your backend database, from where you are going to get the data, perform the ETL or ELT, and then use it to perform various data and analytics. So basically, when we use Azure Databricks, this data pane always remains in the customer cloud account, and it will not be accessed or exposed to Databricks cloud account. So this makes sure that there won't be any data leakage, and the data will always resides in the customer premise, basically. And in order to basically consume or trigger these various Databricks web application and notebooks and jobs and queues, there are multiple ways. So you can use REST API. So if you are working on a local development platform like Visual Studio, then you can use REST API to authenticate and invoke Databricks control plane in the background, which is only, let's say, allocated for your team or your instance. It also has closer integration with single Azure AD, so you don't have to do any additional complex setup. So if we are using, like, most of the enterprise organizations are using Azure AD, so you can use single sign-on to sign into the Azure Databricks. So only authenticated and authorized user with certain permission can log in into your Azure Databricks workspace. So yeah, this is the overall architecture of Azure Databricks, where we have control plane and data plane. So control plane is fully managed by Databricks in the background. So they have their own setup. Basically, whenever from the Azure portal, when you create Azure Databricks, in the background, it will allocate some space, memory, and all the required configurations to make sure that you can focus on your application development, and it is being handled in a governed and secured way. with a closer integration with customer cloud account. In our Azure case, it will have a tight integration with Azure subscription, and also various authentication inbuilt features are available, like integration with Azure AD. So you really don't have to spend a lot of time maintaining additional server, as well as setting up configurations to for Spark or any Azure single sign-on. So this is the overall architecture. Now let's look at a few of the components that we have on Azure Databricks. Like we have already looked at the front page of Azure Databricks, and in a while we'll also look at the demo. So we have like first component is Azure Databricks workspace. So if you go to the workspace, basically you can create notebook. You when we talk about notebook, you can write your code into multiple languages. It can be R, Python, it can be Java, or it can also be Spark. It can be Scala or PySpark. In addition to that, it has inbuilt integration and connectors available to create visualized dashboard. So it has connectivity with Power BI. It has connector for Tableau. So with a very small amount of line of code, you can also create dashboards in the same tool on the top of data that you have. Then library. So basically, you can use various open source library available from different repositories, like it can be Python, Maven. So you can connect to those public repo and use all the packages to create your data solution. It has closer integration with repo as well. So if you want to create a continuous integration and continuous deployment solution with Azure Databricks, then yeah, basically it has you can integrate your Databricks solution with Azure DevOps. Azure DevOps repo, you just have to provide the link of your Azure DevOps repo, and every time as soon as you create, let's say, your source code, it in the background it will automatically sync and see all your source code inside the repo. And once you are ready with your code, you can create CI/CD pipeline as well in the DevOps. So as soon as there is a commit, you can trigger your CI/CD pipeline so that your source code will be available across all the development, test, acceptance, and prod environment. And works in the workspace, you can also create experiments. So these are basically machine learning experiments which you can create to build ML model, and also maintain do all the governance around it, like machine learning model repository, feature management, everything can be done. Then second is interface. So basically, this is the interface, the Databricks workspace UI, from where you can perform multiple activities. In addition to that, you can also use REST API to trigger or to perform multiple activities with Databricks. Then the third component is data management. So yeah, it is one of the major and crucial part of Databricks, where we have data DBFS, Databricks file system. It is an abstraction created on the top of Hadoop open source data format that we have. So you can also store data in DBFS. You can also work with database. So basically, you can create tables, and you can also work with databases as well. And it has its own meta store, where multiple metadata will be, let's say, recorded and present. So while working with open source technologies like Delta Lake, it supports ACID transaction, it supports schema enforcement, as well as time traveling. So we are also going to, these terms might be new for you, but in the upcoming sessions, we are going to cover each and every topic in detail. As this session is focusing on fundamentals, we will continue with the other components. So from the competition perspective, it provides clusters. So basically, if you want to run any of your source code or notebook in Databricks, you have to create a cluster first. In addition to cluster, it provides multiple Databricks runtime environment. So these are the in a pre-built runtime environment, basically created on the fly, where multiple packages will be available. So one of the example can be Databricks runtime with support of ML flow, let's say. So all the standard packages which we are using to build machine learning model, let's say, it will be available as a part of this Databricks runtime. So you don't have to spend any time configuring or installing those packages. And it can also work with the pool. So ideally, once your Databricks workspace is up and running, once you create a cluster, it takes around like 4 to 5 minutes to create a cluster. But if you are working in a very environment where you need to make you where you want your cluster to be available in a very less amount of time, then you can basically create a pool. And when you create a pool, it will basically allocate certain amount of servers for you in the background. So when you create a cluster, it will be up and running in just 1 minute or so, instead of taking 5 minutes. And once your Databricks notebook or your application is ready, if you want to schedule those notebooks to be run at a certain frequency, then you can also create Databricks jobs, which is one of the feature of computation management. Then another component is machine learning. So basically, this is being mainly used by data scientists, where you can create your experiment, you can create your feature store, as well as also you can create multiple models, and you can manage your whole machine learning model life cycle. It provides you a centralized repository called MLflow, where you can maintain your full machine learning application as well. Then the last component is data management. So yeah, as we covered at the beginning, security and data leakage and working with data sensitive, the in order to overcome those challenges, basically Databricks has inbuilt feature where you can create user groups for authentication, authorization, as well as ACLs. So even within the team, you can restrict what different team members can do. Let's say there is a team of data engineering, they can only get access to the data to perform ETL. There is a team who, let's say we have BI developer in the team, so they can only create the BI, basically Power BI reports inside your Databricks cluster. So such kind of granular level of authentication and authorization can also be managed with Databricks. So now, after going through the architecture of Databricks, let's look at few of the Databricks Lakehouse platform use cases, which are being used in real time by many of the enterprise organization nowadays. So basically, Databricks, as I mentioned, it is an abstraction created on the top of Azure, on the top of Databricks platform, to be used by Microsoft Azure services. So it has complete integration with the various services available in Microsoft Azure. So you can connect very easily with Datafreak, Data Lake Storage, Blob Storage, Event Hub, and Cosmos DB with a with a few line of code, without performing any additional configuration. You can connect to all these integrated services, and once the curated data is available, you can also basically use the inbuilt connector to connect with Azure Synapse, Power BI, and machine learning. And in order to create a secure platform for Databricks, it has integration with Azure AD to perform single sign-on, and also you can use basically Azure AD group via scheme to avoid any additional configuration. With a single click of a button, you can get unified billing, and even the whole cluster will be ready. And it has full integration with DevOps, where you can enable continuous integration and deployment for your application as well. Then if you look at like few of the use cases, then you can create an end-to-end solution basically for the enterprise, where you can use Azure Active Directory for the authentication and authorization via single sign-on. You can use data lake storage to make sure that all your data is available in data lake storage, which is basically a cheap where basically a platform where different type of data can be stored, and it is a cheap storage platform. You can use Data Factory for the orchestration with Databricks to create your and operationalize your production workload. You can use machine learning, Synapse, and Power BI to create reports. And you can also use Azure DevOps to enable continuous integration and continuous deployment, and virtual network to enhance the security of your Databricks platform by using custom VNet or custom bubble network. And if you want to create a real-time data application, then yeah, we can also use Azure Event Hubs. Um, So these are few of the use cases where we can use Azure Databricks with the current Azure native services to create end-to-end data and AI solution. So it will basically accelerate the machine learning on big data. So you can, it has inbuilt support for ML ops. It has closer integration with Azure DevOps. So you can basically continue working on all your data engineering and machine learning use cases without any additional efforts. Faster modern data warehousing capabilities. So you can create an automated solution and orchestration with Data Factory, Data Lake Storage, Delta Lake to create Lakehouse platform, and it can be consumed by your BI and data business analyst. It basically boosts the productivity with high collaboration where different teams can work together on a same platform. And as we have already seen, it has complete and very closer integration with most of the Microsoft data and analytics services. In order to support and work with huge data sets, you can also work with a smaller data set. So basically Databricks has multiple type of cluster, single node cluster, and also so you can use the single node cluster to save some cost and also create your smaller scale jobs to create your data and AI solution. So yeah, let's now let me go to the basically the UI page. This is how the Databricks workspace UI looks like. From here, you can basically select what kind of which team you belong to and what kind of solution you want to work. So this is basically a community editions. You are able to see only one option, but in this drop down, there'll be data science and data engineering. There are two more pop up. One for the business analyst to connect to the BI tools, and there'll be one more pop up to perform Databricks SQL analytics. Then if you can select the feature of Databricks which you want to use. Then this is how the workspace look like. So basically this is the shared folder where you can create multiple basically source code or notebooks which you want to share among all the team members, let's say within the team. And this is also a folder where you can actually also create multi, you can import, export, delete, rename, or create different notebooks, libraries, folder, or experiment. And in addition to that, you can also set some permission. Then this is the recent section where if you have worked on any notebook recently, then that will appear here. This is the overall search page where you can look for, let's say, notebook, you can look for experiment, you can look for data that you have. This is the component for data management, basically, where if you go to the create table, you can upload any of your data from your local desktop. You can upload data from AWS S3. You can, this is the Databricks file system, which is an inbuilt storage provided by Databricks, where you can store any of your data. Or if you want to use other Databricks sources, then there are multiple connectors available. So you can use Amazon Redshift, Kinesis, Cassandra, Snowflake. All the inbuilt connectors are available. So without any additional configuration, basically you can consume data from multiple sources. And also these are the partner integrations available. So there are like these are the limited like you can use Click, you can use Teach, you can use InfoWorks. These are the inbuilt partner integration available, which you can use with your Databricks platform. And this is basically the compute. So you before you can run any of your data workload on Azure, you have to create a cluster. So if you create a cluster, let's say I will give the name development. These are the multiple Databricks runtime versions available. So if you go down like these are like Azure Databricks keep updating this runtime version. So you can use 8.4 if you want to, let's say, work on a Scala or Spark 3.1.2. If you want to work with building machine learning model, then you can use this Databricks runtime, which comes with the GPU and also with some inbuilt libraries. So likewise, you can select basically the Databricks runtime, and based on the Databricks runtime, the charges will be different. So you can understand more about it. And basically, Here you can select the availability zone as well, and this is about the Spark configuration. So if you want to set up any additional configuration, then you can use Spark. You can set define the Spark configurations here, and once you click on the create cluster, the cluster will be created, and you can run your workload on the top of this cluster to run your end-to-end solution. Then basically, if you go on to the right hand side, this is the page where all the data governance and administration can be done. So this is basically the user settings. So you can set up your password if you are not using single sign-on. But for most of the enterprise organization, they are using single sign-on with tools like Azure AD. If you want to integrate with Azure AD Git integration, then also it has inbuilt integrators and providers available. So you can integrate with GitHub or Bitbucket Cloud with a click of a button. So you just have to create a token, link the repo that you have in GitHub or Bitbucket, then you are done. Then the notebook settings. So these are the settings which you can configure from centrally from here for all the notebooks that you are going to work upon. These are the settings for model repository and the language settings. So yeah, you can also work with multiple languages. So these are basically the user customized settings that you can set up and configure while working with Databricks for the local development. Then this is mainly used for the administration purpose. So here you can add multiple users. So if you want this cluster to be accessible within the team or with multiple people, then you can add different team members by just adding the username or email ID, and then they will be able to access the cluster. And you can also set multiple permissions, like do you want them to be admin or do you want them to create a cluster, that can be also managed here. Then global init script. So when different team members are working, let's say we have data engineering team or data science team, what they want to do is as soon as their cluster starts, they want to install certain packages immediately without taking any manual actions. So they can create a script and add that script inside global init script. So whenever there is a cluster restart, the packages will be installed automatically, which will reduce the manual overhead as well. And the third section is about workspace settings. So it is, yeah, we are going to deep dive this into the further session, but you can perform access control to perform the granular level of access about your workspace, about your cluster pool and table access control. Then there are a few administration settings regarding storage and how you can connect to the external system. And then also there are a couple of advanced settings available, and like how if you want to avoid any, let's say, access attack or notebook exporting, because when you are working with multiple like bigger enterprise organization who are working with sensitive data, then you don't even want your source code to be exported. So such feature can be configured from here. And then this is the manage account section, where you can manage your Databricks account basically. So this is how the overall like workspace UI looks like, and we can deep dive for we are going to deep dive for further in detail about all the sections. But yeah, I think that's it from my side from today's session. And I think I hope and the session was informative for you. And now I think if there are any questions, we can take it up. So yeah, I would like to thanks everyone for joining the session, and I will hand it over to Asirvad to inform me about any questions that we have in the channel, which can be taken up now.
Thank you, Sagar, for your informative session. As far as I can see now, we don't have any questions yet. We can wait for a minute or two, and if there are no more questions, we can call it off for the day.
Yeah, thanks for the update, Asirvad.
You're welcome. In the meanwhile, Sagar, can you talk about what you'll be exploring in the next set of sessions, which are the part of the series?
Yeah, so after covering the fundamental of the what is Azure Databricks and what is Lakehouse platform, In the next session, we are basically going to deep dive about the Azure Databricks platform from the administration perspective. So how you can deploy and create your Azure Databricks workspace, how you should configure with best practices so that you can collaborate efficiently within the team, and what are the different features available for data management and governance and integration with tools like Azure AD for single sign-on and scheme. So that will be the next session that we are going to focus on.
That sounds interesting. Since we don't have any questions yet in the Q&A, I think we should call it off for the day. And before we sign off, I'm gonna share about some of the upcoming events in our community. So there are a couple of more events that are coming up later this month. I hope you people are interested to join in. Apart from that, if you want to join in any of the communities, you can always join into any of the communities. This session was brought to you by Azure Developer Community Bhubaneswar. As you can see, there are way more communities across India who focuses on upskilling professionals like you and me in Azure, so that we can grow on our professionals way. Okay, there's a question. There's a question here in the chat window. I'll read it out for you, Sagar. So,
Yeah.
so Vijay is saying that I'm a bit confused about ADF and Databricks. It seems similar. In ADF, we can use Databricks.
Yeah, I think this is a really good question. So basically, I can try to differentiate both of them. Both comes with a different purpose, and indeed, we can use Databricks within ADF. So Azure Data Factory is an orchestration tool, basically where you can try to orchestrate your overall workflow. So let's say you want to copy data from AWS S3 to ADLS Gen 2, and then once the data is available in ADLS Gen 2, you want to perform some ETL, and then yeah. So if you want to do that, you can create a data factory pipeline, which is basically acting as an orchestrator, uh, where first you can add an activity to copy data, and then second you can add an activity which is basically calling the Databricks notebook, where you can write a logic in different languages to perform ETL. Now, coming back to the Databricks, it is basically a unified analytics tool which provides data management, which provides compute management as well as data governance as well. So features like single sign-on, etc. And within Data Factory also, we have Data Factory data flow, where you can do some data transformation. But if you want to do some advanced level of ETL or ELT to create automated data pipelines with inbuilt support, let's say with multiple storage, public cloud storages like S3 or ADLS Gen 2, then you have to use Databricks. And in Data Factory, you can indeed basically call Azure ML services. You can write your notebook, but Databricks is basically using Delta Lake, and it has also connectivity with tools like Power BI. So on the top of data that you have, you can directly connect to the BI tool, as well as you can also write your machine learning model to create the insights. So Data Factory is basically an orchestration tool where you can orchestrate the overall flow to create your data solution. But Databricks, it is mainly focusing on creating an automated data solution. It can be ETL, it can be ELT, with an addition to closer integration with BI tools like Power BI, Tableau, as well as you can also use ML Flow to manage your whole machine learning lifecycle, which is not possible within Data Factory. So
I
yeah,
hope
is
it
it?
answers. I hope it answers well, Vijay. Uh, let's see if we get any more questions, Sagar.
Yeah.
So guys, if you have any questions, please do ask in the chat window, and I'll get it answered by Sagar, who is our subject matter expert in this area. So don't feel shy, and please ask your questions if you have any. Okay, so I guess we don't have any more questions for the day. So let's call it a day for us. Thank you for joining in on a weekend. Thank you, Sagar, for accepting our invite and joining us, taking some time out of your weekend and hosting a talk. It was a pleasure to have you. Thank you, Sagar, for joining in, and thank you, folks, again. Have a good day and take care.
Yeah. Thanks a lot, Asirwad, and thanks everyone for joining the session. Yeah. Wish you a nice day.